Okay, in this problem, we are told that we have this function g that is 1 over little g, so the reciprocal of little g, and little g is the inverse of f. So let's collect that information. It's telling us that capital G is equal to the reciprocal of the inverse of the function f. Now notice there's two symbols, the power of minus 1 there and the power of minus 1 there, that we've used correctly, but in the different context of the symbols that are on our page. The first one, this one here, is taking the power of a function. So I can read that as the inverse of the function. And this one here is saying, after you find out what this expression is, take it to the power minus 1. So this is an expression to the power minus 1, which means take the reciprocal. So in the context, it makes sense. I mean, you do have to be careful when you read it, because if you just read to the power minus 1, you need the correct interpretation by reading what's around it to get it correct in your head. So our job is to find the derivative of g at 2. Well, first, let's just find the derivative. So we'll bring the power down by the chain rule. We write minus 1 and copy everything that's in the brackets, and then drop the power by 1, so minus 2, and then we take the derivative of the inside. So that would be f inverse prime, the derivative of that, evaluated at x. Now I've created a little bit of a problem for myself. I don't know what the derivative of the inverse is off the top of my head. Maybe I can find a formula, though. Maybe we can prove a little formula off to the side. If we say y equals f inverse of x, and we're trying to find the derivative of y, maybe we can try to solve this for y prime somehow. And if we use implicit differentiation after taking f of both sides, what we'll get is f of y equal x, and taking the derivative, we get f prime of y, and then y prime multiplied by y prime, and the other side we get 1. So now solving for y prime, look at what we get. We get 1 over f prime of y, and y specifically is f inverse of x. So there's a nice little formula that we can use to deal with the derivative of the inverse. Now, in particular, we're supposed to find g prime at 2. So let's plug in 2 for x on our next step so we can try to figure this out. So we have minus 1, and then all of this stuff in brackets to the power minus 2. Okay, so next we calculate f inverse at 2. Now, we weren't given f inverse at 2. However, we were given f at 3 equals 2. So if we look back up to the top here where we're given in the question, we can say that f inverse at 2 is equal to 3, because f at 3 equals 2. So it switches around if you take the f inverse of both sides of that equation. So in this bracket, we can write 3. Now, to deal with the last part, we would have 1 over f's derivative and f inverse evaluated at 2, which we already figured out is 3. So f's derivative at 3. Now, luckily in the question, it told us that that is 1/9. So on our next step, we can plug things in. We get minus 1 over 3 squared, so 1 over 9. And f prime at 3, it told us that was 1/9. So this would be multiplied by 1 over 1/9. And now, conveniently, we have a 9 and a 1 over 9 going away for us on the bottom, so the whole thing is equal to minus 1 multiplied by 1, which is just minus 1 as our final answer. Okay, so we did all of this work without knowing what the function f was, and of course then what the function g was. This is all just some theoretical work that we've given some basic details. I think it might be kind of nice, even though it's not really part of the problem, to try to solidify our understanding by maybe coming up with a function f that has the properties that are given. So if we try to dream up a function that has its derivative when we plug in 3 to be 1/9, let's see if we can do that. Well, how about we pick f of x to be 1/9 multiplied by x. So no matter what, after we take this derivative, we'll get 1/9. Doesn't matter what we plug in. Now we also have to make sure when we plug in 3 to this function that I just wrote down, I want to make sure that I get 2 out of that. So I'm going to add 5/3. That will make sure that when I plug in 3, I get 2, because I plug in 3 and I get 1/3 plus 5/3, so 6/3 is 2. Okay, now to play out this problem, we'll also need the inverse of this function f before we can plug it into g. So f inverse, how would we find that? We would subtract both sides by 5/3 and then multiply both sides by 9. So the inverse function would be 9 multiplied by x minus 5/3. Now we can write down what g is equal to. So g of x is equal to the reciprocal of what we just had, so 1/9 multiplied by all of x minus 5/3 to the power minus 1. So let's take our derivative and see what happens. So g prime of x is equal to 1/9 comes along for the ride, and then our power rule brings minus 1 down. By the chain rule, we rewrite what's on the inside of the brackets, and then we drop the power by 1, and our whole derivative of what's on the inside is just 1. So we're done at this point. Now, when we plug in g prime at 2, we should expect to get a particular result out of the deal. So let's see what happens. We have minus 1/9, and then in the brackets we have plugging in 2 for x, or 6/3, minus 5/3 would give us 1/3. So 1/3 to the power minus 2. Let's try to unwind this a little bit more. We'd have minus 1 multiplied by 1/9, and then 1/3 to the power minus 3. Minus means that we have to take the reciprocal and to the power 2. So we'd have a 9 on the top, and again we get those 9s canceling out. And our result, we kind of knew that this should happen. If everything went correctly, we also got minus 1 in our example. Now, unfortunately, this idea of just making up a function for f is not really a solid answer to the problem, because in the original problem, we are not told what f is, of course, and we are really not sure that there's just one answer to g prime of 2. After we go through this work, we decide, okay, there is just one answer for g prime of 2. It has to be minus 1. And that's an example of how that can occur below, where we also found an answer of minus 1. But if you just came up with an example for the function f, and you went through this process and found g prime and g prime of 2, and you found that the answer is minus 1, you still wouldn't know that there couldn't be other possibilities. So it does give us a feel for what's going on, but it's not a good solution to just come up with an example for f. And one last comment to make. If we scroll back up to the top where we did this work to find the derivative of the inverse, you would want to make sure that this inverse is actually differentiable. But they did tell us in the question that the f was differentiable. So its inverse would be differentiable on its domain. So I'm going to add that comment in just a note off to the side here. I'm going to say that, note, since we are given in the problem that f is differentiable, we are told that, we can conclude from that that f inverse is differentiable on its domain.